I lead the photonics team here at CMC Microsystems. Today I'm going to tell you a bit about CMC and the products and services that we offer to help you get cost-effective access to Microsystems technologies, hence the title of my presentation, Lowering Barriers to Technology Adoption. So CMC is a not-for-profit corporation founded in 1984 with the mission of enabling research excellence in micro-nanotechnologies in Canada by providing a national infrastructure and a path to commercialization for related processes, devices, components, and systems. We accomplish this by delivering products and services in the categories that are summarized on this slide. So design tools, that could be software that you download to your own machine and run on your own machine, or cloud-based access. Microfabrication, packaging, and assembly services to create working prototypes, and equipment and services for prototype testing and platform technologies. Also training, support, and networking and contract engineering services. CMC manages Canada's National Design Network. And Canada's National Design Network is comprised of more than 1,200 faculty at 67 member universities and colleges across Canada, as well as their graduate students and postdocs and their collaborators, including 1,000 companies, and CMC Microsystems. We act as technology brokers and provide access to leading-edge tools, technologies, and solutions to support Microsystems research, along with related training. Some of the outcomes related to our mission are summarized on this slide. In addition, we also provide our services to a growing number of international clients. Growing our client base allows us to support a broader range of technologies and more frequent access to fabrication runs, which benefits all our clients both inside and outside Canada. Units, which we call CAD, FAB, and Lab. CAD means high-performance CAD tools and design environments available as software that you run on your own machine or as cloud access, as well as related materials such as user guides, application notes, training materials, and courses. FAB means services for making working prototypes, multi-project wafer runs with affordable access to industry-class foundry-based technologies worldwide, assistance getting prototypes made at university-based labs, along with value-added packaging and assembly services, all supported by in-house engineering expertise to help you make first-time right prototypes. The lab means access to test equipment from our loan pool, platform-based technologies, and contract engineering services. To accomplish all this, we maintain business relationships with partners and suppliers around the world and leverage those relationships for the benefit of our research clients. A summary of that supply network is shown on this slide. We seek out the best technologies from around the world, wherever they may be found, and make them available to our clients. So CAD, just describing a bit more about the CAD business unit. We offer state-of-the-art software for successful design in the areas of microelectronics, MEMS, microfluidics, photonics, and embedded systems. These are available to academic researchers and to small and medium-sized companies. We have over 40 computer-aided design tools and design environments, a secure distributed private cloud for hosting, and user guides, process design kits, application notes, and training materials and courses. We have the CMC CAD Compute Cluster, which is a dedicated group of servers enabling researchers to improve the performance of large computational tasks. And the CMC Cloud Design Environment provides researchers with secure, high-performance, remotely accessible CAD resources. And finally, CMC is a Cadence Cloud Passport partner serving academics, which means that you can get access to Cadence tools delivered by a CMC Cloud. In the FAB business unit, we offer access to low-volume prototyping and dedicated runs through supplier partnerships. So we offer multi-project wafer services and related fabrication services in a variety of technologies. This means you get simple access and reduced cost for working prototypes because you purchase only the portion of the design space you need, and you benefit from our expert assistance to help you achieve first-time right designs. We also offer dedicated and/or custom runs on a case-by-case basis, and CMC delivers packaging and assembly services with related engineering support and consultation. Here are some highlights from the last 5 years in terms of prototyping. We prototype about 300 designs per year, and about a quarter of those are photonic designs, and most of those photonic designs are silicon photonics, about 80%. Microelectronics also continues to be an important part of our portfolio, as it always has been. And we also do a lot of MEMS and several other technologies. We also support multi-technology integration and co-design, for example, electronic photonic co-design. Here I list some examples of the microelectronic technologies that are available from CMC. Our offerings range from leading-edge FinFET and FDSOI technologies to more mature CMOS technologies such as 0.18 micron and 0.35 micron. You will notice several global foundries technologies in these examples. That's because CMC is a channel partner and multi-project wafer reseller for GF technologies in the Americas, supporting university and commercial clients with both multi-project wafer and dedicated runs. This significantly broadens our microelectronics and silicon photonics portfolio. For a full list of technologies and descriptions, please follow the first link on this slide, and our fabrication schedule is available at the second link. The GlobalFoundries 90WG platform features monolithic integration of RF and digital elements, silicon photonics, and fiber coupling, an electro-optic PDK that enables co-design of both electrical and optical components, and best-in-class performance in key parameters, things like SOI waveguide loss, undercut thermal phase shifter, PN junction phase shifter, input-output fiber coupling loss, Mach-Zehnder interferometer, and photodiode bandwidth. This technology supports optical communications applications, such as 5G backhaul and front haul in both the C-band and O-band, short reach intra-data center in the O-band, data center interconnect in the C-band, and chip-to-chip interconnect in the O-band. The next generation of this technology is called 45CLO. It will be available this year and will feature even better performance. AMF is our workhorse silicon photonics process, with most of our client silicon photonic designs being fabricated in this process. It supports a standard set of features summarized here, and we supply design kits that include a library of characterized and verified standard cells from AMF. With this technology, you can make photonic integrated circuits that include modulators, detectors, stripper ridge waveguides, gratings for fiber coupling, deep trench and nano tapers for edge coupling, as well as diffraction or arrayed waveguide multiplexers and demultiplexers and filters, such as ring and disc resonators and Bragg gratings. We are collaborating with IBM and AMF to adapt the fabrication process so that a compliant polymer connector technology developed by IBM can be used to readily couple fiber arrays to chips with low optical loss. And this connector technology will be available later this year. Here we see a number of silicon photonics designs handled by CMC and fabricated in various foundries in recent years. The numbers shown here add up to more than 580 silicon photonics designs going to fab since 2008. Overall, in photonics, we've had more than 800 projects going to fabrication in the same time period. We can observe a few trends here that, well, activity in silicon photonics is increasing, and the size and complexity of designs are both increasing as well. These designs involve both university research and companies, and a number of these designs also arise from training courses that CMC runs in collaboration with the universities. So larger, more complex designs are enabled by design automation capabilities. So let me describe some of those capabilities that are currently available in process design kits that CMC provides for AMF silicon photonics. At the moment, we provide 3 different process design kits based on different tool sets to accommodate user preferences. There's one based on Tanner L-Edit Photonics, another based on Lucida and Tanner tools, and a third one based on Mentor Pixis. These PDKs include all the parameters that you need to set up the tools to design into the process, for example, layer definitions. They also include libraries of foundry supplied black box cells and P cells, also the ability to make user created cells. Caliber design rule decks for rule checking, a tiling script in Caliber for doing dummy fill to meet density rules, and also user guides, a bunch of documentation like user guides, AMF process and design manuals, and so on. One other thing that I would mention are a compact model library based on numerical simulation models. Let me just say a bit more about some of the features of the different PDKs. In the LEdit Photonics PDK, there is C and C++ script of user programmable interface functions for layout creation, so for automating layout creation. Also, programmable T-cells are included with LEdit. And you can do a preliminary DRC in LEdit, so you can do design rule checking during the layout creation process. In the Lucida Tanner PDK, Lucida IPKIS Python development environment and Python source library, cell library, also an interface with Lucida IPKIS and the filter tool interface with Tanner LEdit and SEdit, and device simulation models using the Caffe simulator. In the Pixis PDK, we have an integrated caliber and layout environment, and also CMC supplied programmable cell library. Again, these are features that allow for greater automation in the creation of your layout. So how does one learn how to design into silicon photonics? Well, one way is to take a training course, and we offer training twice a year. We've been doing this since 2008. It's a collaboration with the University of British Columbia. And this training is part of an initiative called SciEpic, which stands for Silicon Electronic Photonic Integrated Circuits, which is a program led by Professor Lucas Krastowski at UBC. So the course begins with a workshop that includes both theory and hands-on training using the CAD tools and the design environment. Now, the last couple of courses have been delivered online because of COVID-19, and the next one will be as well. Anticipating that the next one will be in the May-June timeframe, but the dates haven't been finalized yet. So following the workshop, the students go back to their home institution and work on a design project that they have proposed. And throughout the process, they receive guidance from the instructors and engineering support from CMC. The finalized designs are sent for fabrication on a CMC brokered multi-project wafer run. And when the fabrication chips are received, they are tested by the students, who then submit a final report to complete the course. So the test results inform the next design cycle, either by other students in the course or as a follow-up activity by the same student. And hundreds of people have been trained. The results are substantive, often resulting in publications by the students and or follow-up research that subsequently gets published. Some of the students have gone on to spin off companies, and companies who have participated have gone on to develop their own in-house silicon photonics expertise. We offer 2 courses per year, one in passive silicon photonics and the other in active silicon photonics. So that the next course will be in active silicon photonics, and it will be offered in the May-June timeframe, with dates to be determined soon. So stay tuned if you're interested. More info is available by following the link on this slide or by contacting us. Now let me talk about our new subscriber pricing. This new pricing is available to subscribers and made possible because of support from the Canada Foundation for Innovation, CFI, and sponsorship funders. I'll describe sponsorship in a subsequent slide. Prices are per block or per square millimeter, depending on the technology. And there are 3 pricing categories: $100, $1,000, and $2,000. For example, AMF Silicon Photonics, the peer-reviewed price is normally $5,400 per block of 8 by 3 millimeters, but under this new pricing, it would be only $1,000, which is a huge discount on pricing that is already highly discounted for academics in Canada. These low prices will be available until at least March of 2023. Please note that before these discounts are applied, CMC's usual eligibility checks and peer review are employed in order to ensure the effective allocation of resources. Now, CMC employs a subscription model for academics in Canada. So by purchasing a subscription, you can get preferred access to our products and services. So there's a research subscription for $1,000 that would cover a professor and his or her research team. And that gives them unlimited use of Cadence, Mentor, Synopsys, and Xilinx, and other tools, all the other tools, but limited to 5 concurrent user instances. And additional packages can be purchased if they need more than 5 concurrent instances. The subscription also includes access to cloud-based and high-performance computing resources, engineering support, and training materials, and it also gives them access to subscriber pricing, which I just described, on over 20 fabrication service options, also short-term equipment rental and training courses. In addition, there are other subscription options. The education classroom one for $2,000 would cover all the professors and instructors at an institution, so it would be purchased at the institutional level. And that gives unlimited classroom use of a whole bunch of CAD tools, and the licenses are provided based on student enrollment per course, and there can be an unlimited number of courses within the subscription period. And finally, the Research Plus subscription would be also purchased at the institutional level and would cover all professors and instructors at an institution, would give unlimited CAD access for classroom, and also unlimited CAD usage for professors with valid research subscription at the same institution. So let me describe industrial sponsorship. This is an industry sponsor opportunity. So companies can choose a chip fabrication technology and topic area that is of interest to them, and CMC takes care of the rest. So what you get as an industry sponsor, you get to stimulate the research community and contribute to graduate student skill development in your area of interest, identify potential future partners, explore topics in the design and manufacturing space, and you can submit your own designs alongside those of the students and benefit from CMC know-how. As a professor, you get low-cost access to silicon that allows you and your students and your research staff to test out new ideas and to publish. And as a student, you receive mentoring, knowledge gained in hot industrial topics, and affordable chip fabrication. Also exposure to possible future employers. So if you are a company and you're interested, please contact us. If you're working with a company who may be interested, please encourage them to contact us. CMC offers access to platform-based microsystems. For example, an FPGA/GPU cluster, which is a cloud-based, remotely accessible compute infrastructure, specifically designed to accelerate compute-intensive applications such as machine learning, training and inference, video processing, and so on. Also access to real-time embedded systems lab, focusing on real-time embedded software and systems, FPGA development boards for rapid prototyping, wireless sensor network kits, and photonics toolkits, which are under development. These are going to be packaged research and education prototype boards, and they'll include standard photonic blocks using CMC supported platforms, AMF and GlobalFoundries 9WG. And so there'll be chips that include both passive and active photonic devices, and these will be packaged in a cost-effective standard IC package with DC and RF controllable circuits. They can be used to learn basic optoelectronic functions and device testing. And the kits will include the device designs, the design flows, and simulation scripts to get you started on your own designs. And with this, you can learn some of the more challenging aspects of photonic design before investing in chip fabrication. So stay tuned for further information about this. It is under development. We also offer test equipment that can be borrowed from our test equipment loan pool, and engineering services such as design kit development and support, also contract engineering services, for example, to design a chip or work with a foundry to customize a fabrication process for your application. So Quantum is a new adventure for CMC. So CMC is a member of the IBM Q Hub in Canada, and we have a team of quantum coders that are located at the Institut Quantique in Sherbrooke. So we take computational problems from clients, code them to run on the IBM Q machines, and help them interpret the results. The high-end machine that we can get access to right now is 65 qubits, but IBM has a roadmap leading to 1,000 qubits in a few years. So this is an exciting time, and we expect things to progress rapidly in this field. We also have a partnership with the Canadian company Xanadu, and they make photonic qubits based on Gaussian boson sampling. They currently have a 24 qubit machine. CMC and Xanadu have launched a program that we call the Xanadu Quantum Sandbox. So through that program, you can get exclusive early access to Xanadu quantum computers. You can get free cloud time on Xanadu systems for up to 6 months, free expert support from quantum computing experts at CMC and Xanadu. And the goal of the program is to identify and explore exciting new applications for CMC's near-term quantum computers. So we've had one competition so far with 5 winners who are accessing the Xanadu Quantum Sandbox. And we will, stay tuned for future opportunities to get access to this program. So I've already mentioned the SciEpic training in silicon photonics, but we offer lots of other training as well and other CMC organized events. So for example, we plan to offer hands-on training in 12 nanometer FinFET process coming up in March, and this is to prepare designers for the significant challenges of designing into this leading edge technology. And we're also we're working with 2 other organizations to deliver a workshop on gate-based quantum computing that is happening right now. And there are other events listed on our events page, and let me just show you what the upcoming ones are. I list a number of them here that are coming up in the next couple of months. The very next one is the Entrepreneur Series with Frederick Napke, and he will describe his experience as an entrepreneur launching a company, and that'll be quite interesting. We've had a number of interesting talks in this series. And also the TEXPO, which is the graduate student research competition, it's an annual competition that offers grad students across the National Design Network an opportunity to demonstrate their novel applications of microsystems and nanotechnologies to industry and to academic representatives, and all the while also they have an opportunity to compete for prizes, so compete for money. So more details on our events page. Let me just mention that CMC belongs to industry consortia in order to promote the common interests of the members and also stay abreast of the latest technology and market trends, and to connect with suppliers, partners, and clients. And let me end there and say thank you for your attention.